Hello again. Talking NAT at the moment, network address translation, and I'll do this in two parts, I think. One is going to be, well, the first one's going to be maybe three parts, just thinking about it, sorry. The first one's going to be pure NAT or network address translation. We're going to use it for port forwarding, where we're actually connecting from one address to another, and we're going to go through the process of what NAT really is. The second one I'll do would have a pool of addresses, still NAT, and then the last one we'll do a thing called PAT, which is port address translation, but it actually does network address as well, so it's network and port address translation in the third video of this little series. So it's stuff we use it daily. Actually, my home router runs NAT because I hide, or actually PAT, NPAT. It hides my LAN behind a particular IP address on the outside. Now if I wanted to port forward, maybe I'm running a game on the inside or whatever, in my case, in my sample here, what I'm going to do is have this server. So I've changed this network over a little bit. I've now got a server up in this network up here. What I want to do is, if I get hit on this external address over here, not this internal one, so this external one over here is 200.20.20.1. That connects to my ISP, 24 bits in the subnet mask, so that address of gigabit 01 on router 2 there, I want to have an external client connect in to this address, then get forwarded to this PC. So this is actually hiding in what's effectively a demilitarized zone. Ooh, cancel that one. What have I done? Always be careful of that. So a demilitarized zone is you want to give some punters access to this network, but only a certain few protocols access from the external part of your network, or from the internet actually, not your external part of your network. It's not your network, it's outside, and hide the inside. So this is what we're going to set up. First up, demilitarized zone. So what I'm going to do is, first of all, just show you what our configs are. So on my PC here, I've set up this little network. So this PC lives out on the internet somewhere. Its address is 200.10.10.10 and its gateway is 200.10.10.1, which is this interface of this router up here. On the other side of this router, we're connected to 200.20.20.2, and that connects down to 200.20.20.1 down there. So this machine won't be able to ping anything in there. We're not running any routing protocols in here. We just have an IP, static IP. I have said my DNS server is going to be this external address, and that's what I want. What I want to do is have this server running DNS and HTTP. It's going to be a web server, and the DNS service is going to run on 200.20.21 there. So all in IP version 4. Okay, so let's just check what I can ping. I have pinged stuff before, so let's just go back in and make sure I've got connectivity at least. So 200.10.10.1, that's my gateway, so good with that. And then 200.20.20.1, which is, well, maybe I should ping it, shouldn't I? Is the external address of my router 2. Now I want to ping 192.168.30.1, which is this internal network here. See if I've got access to that. So 192.168.30.1, and the host is unreachable. So the router here, if we look at its routing table, and I've got absolutely no configuration apart from the IP addresses, no passwords, no nothing. Show IP route. The only routing I have is the two directly connected networks, that one and that one. Nothing else. So this router does not know where all these networks live, and that's actually what we want. We want to hide this all behind NAT. Okay, so let's hop in and build NAT up. So we'll pop onto router 2 and configure terminal, and we're going to put in one-to-one NAT. Now we're going to use a particular command to start with, which is going to open all the ports across the whole box and dice and then see how we go from there, and then we're going to refine it a bit and close some ports down. Not necessarily close some ports down, but only allow certain ports to come through. So IP NAT is what we're using, and put a question mark, so we say inside source, and our inside source is going to be a static address for this one-to-one. So we're doing static NAT, we're not going to use dynamic NAT. If we had dynamic NAT, we'll have a list, and that's for a next video, and that's an ACL, an access control list. So our IP NAT inside source is static, and we put a question mark in there. We're just going to go straight in and say our inside local IP address. Now our inside local is actually this PC here, or this server. So 192.168.30.10 is going to be my inside local address. So 192.168.30.10, and my inside global is actually not inside, it's actually this external address out here, but it's called inside global. So global implies out into the big bad world, and local implies in. Inside is not too sure what it implies actually. Anyway, 220.21 is going to be my inside global address. So if I show IP NAT translations, then there is a static NAT that says the inside global. So it's handy to know these terms. Inside global is actually my outside interface there. My inside local is my internal IP. In this case I'm playing it with that. I haven't connected anywhere outside yet. Now most times the outside local and outside global are going to be the same IP address, so we're not going through other NATs somewhere else where we are going through, so that's fine. We've actually set it up mostly with that NAT rule there. IP NAT, inside source, static, inside local, inside global. And that's fine. We've got that bit, but there's another bit that we have to do. A little bit like ACLs, we have to actually apply the correct interfaces. So conf t, let's move it over a wee bit, sorry. And my interface gigabit 00 is this interface here, and we have to say what sort of interface it is. So IP NAT inside is what we need to put in there. It's an inside local really interface. If we go to interface gigabit 01, which is this interface, which is our inside global, it's our global interface, we're actually going to type IP NAT outside. So we're running NAT, network address translation, on this system, so let's just have a look at our running config just to have a look. We've got a whole bunch of stuff running on this router at the moment. So we've got IP NAT inside on our gigabit 00, and we've got IP NAT outside on our gigabit Ethernet 01, because that's outside, and we've got our IP NAT inside source static, inside to outside addresses. Okay, so let's have a look and see what's happening. So So show IP NAT translations. Nothing there at the moment, so let's go to simulation mode and let's see what happens if we ping stuff. So let's ping 200.20.20.2. That's the address of this router up here. And we'll follow our ICMP through, so it goes in and goes up and works, comes back and comes in. Let's come back to that in a minute. But let's just show IP NAT translations here. And we've got information. We used ICMP. Our inside global hasn't changed, but now we've got a value 1. It's not the port number because it's ICMP. ICMP doesn't have ports. Here's our inside local, and our outside local and outside global are those addresses there. So we've got information with our show IP NAT translations. Okay. Let's have a look at the next ping go through, and we're going to look at it in this router here. Now our inbound PDU says that our source is 192.168.30.10 and our destination is 200.20.22. Outbound, NAT has happened. Our source is 200.20.21 and our destination hasn't changed, 200.20.22. So it's been NATed. Network address has been translated. So why would we want to do this? Well, these addresses, 192.168, under the RFC, I forget the version, are non-routable across the internet. Now 200.20.20 network is routable, 200.10.10 is routable, so out on the internet we need to go out there with a routable address. 200.20.21 is a routable address across the internet. It's not just one router, it's hundreds. So we can masquerade, if you like, as a separate IP and hide our non-routable address in there. So when the packet comes back, we get translated back in. So our source was 200.20.22, destination 200.20.21. We change our destination back to that, actually based on our table. Don't know why that's smaller now. So it's actually come back in and used this table to translate back to our correct IP, which is our inside local address. So ping is working right through there. Let's ping from, let's kill that one, reset simulation. Let's ping from there to our internal. So I've run a few pings just to test. So now let's ping 200.20.20.1 and let's go through our simulation and see what it's doing. So we ping, it hits there again, and outbound, it's translated it again. Inbound is still correct values. Outbound is now translated through our rules, and it'll forward that to our server and back out again. So at the moment when we look at it, if we show IP NAT translations, we've got inside global, inside local, outside local. We've got different ones in there. This is the one that we pinged from our PC. There's a bunch of spare ones happening. At the moment we can accept just about any protocol, any port, straight through this whole system, because there's no port security on here at all. There's no ACLs, and all we've done when we show our running command is taken this complete IP address and said translate it into that one, or vice versa depending on where the packet initiates. So not the safest thing in the world. We still want packets to initiate, or connections to initiate from the outside and come in and get sent here, but we don't want the whole 65,000 ports available to everyone. So this is not a good one-to-one NAT. It's okay, but it's not good. It'll get hacked and you'll be sorry. So let's clean it up a bit. So conf t, I'm not going to type all that out again, so I'm just going to copy that, and we're going to say no, and I'll paste that, hit enter there. So I still want to have my demilitarized zone, but I only want a couple of ports to be available. Actually, I want this PC to use DNS to come through and HTTP. So at the moment in my services, I have enabled HTTP is on and DNS is on. There's my record. It says that bob.com as an A record will connect to 200.20.21, which is my external address there, and it'll be translated in. So let's have a look at the command we can type in. So IP NAT inside source static. Now let's have a look at it. What we want to do is play with TCP and UDP. So let's do TCP for port 80. Put it in, so the inside local address 192.168, not yet, 30.10, and the port number should be next, which is the local port, so port 80 is web. Then our inside global address needs to be added on, so 200.20.20.1, and again which port we're actually putting on there. Which means we can actually translate the ports. If I said that 8080 was the external port, it will translate not only the IP address but actually the port number to that IP and that port number. So effectively that socket will translate into that socket. But let's not kill ourselves, let's just leave it at that. So let's check if that works in our system. So show IP NAT translations. If we see that, the other one has disappeared, so they do get flushed out of the system. Actually it was a static, so it disappeared as soon as I negated the command. But let's have a look. So the protocol here we're using is TCP. We're saying our inside global is that, and we're listening on port 80, and it'll be translated into that inside local address again on port 80. So let's check if that works. So we're out here. Let's use a device that will actually translate for us 200.20.20.1, and we're still in simulation mode, so let's just capture forward and translate it through and back. So all using TCP, and then HTTP is going to come in and work its way through. Nice. Okay, let's get out of simulation mode. Have a look at our website. Yep, we've got bob.com. Welcome to Bob. Let's have a look at our translations here. So show IP NAT translations, and good, we've got that connection. So the initiating port 1034, that's the initiating IP address, which is this PC out here, and we've translated that TCP. So nice. Let's try something though. I'm going to type in bob.com because I want DNS to work, and I'm going to hit enter there. Now it should fail. Come on, keep going. Actually, you might just go into simulation mode and just have a closer look at that. We'll go again. So there's DNS, and we capture forward, and it's hitting the IP, but our ICMP is coming back to our router saying, no chance, buddy. And we're going to keep trying again, and eventually it dies. that should not be there. Let's go back in again. bob.com. Now DNS does take a while. We'll go back to our real-time mode, and eventually it should come out in either timeout or destination unreachable. Should pop up, but effectively it's not running. So why isn't it running? I'll kill that. Let's ping it again. So we were able to ping 220.21 before. Let's ping. We're actually getting a response. Tricky one though, isn't it? Let's have a look at where we're actually getting a response from. So we'll ping again. ICMP runs in, and it's just being returned straight from our router. It's not doing NAT. So it's running through, and then ping again. And that's because if we show IP NAT translations, we're not translating ICMP. The only rule we have in there is this one, which is TCP port 80. So let's add more rules to allow other stuff to come in. So IPNAT inside source static TCP on port 80 to port 80. So let's change this up a bit. Let's allow port 53 in, and we'll allow it in TCP, enter there, and we're going to allow it also in UDP, because DNS uses UDP to start, and if that doesn't work, because UDP is a connectionless protocol, then it will revert to TCP. So let's see what we've got now. So if we show IP NAT translations, we have options. So at the moment we've got no connections, but we do have these ports available for us. So let's hop out of simulation mode. Let's go back to our devices, and if I ping bob.com, then I'm asking DNS to resolve, and it's come back. So let's just have a look in simulation mode again, what's actually happening. So we've got DNS, so we're going to capture forward. DNS should be forwarded, which it does. The DNS server resolves that IP address to the name through the A records, and then ping actually works, because on our DNS server, we said that bob.com equals 220.21. So DNS has gone through. So let's have a look at our external stuff again. So bob.com says let's use DNS first, and then use web services, and boom, straight through. Love it. So bob.com has resolved from this server through DNS. Let's show IP NAT translations again, and there it is. There's a whole bunch of DNS coming through. In this case, all UDP. Those are the ports that it's used, and then TCP has responded with the website on port 80. So nice. Last bit to show in this lot: clear IP NAT translations, and we need to put an asterisk at the end of it to clear them all, and that closes all our translated NAT material. So if we show IP NAT translations there, we've got nothing outside connecting. So good. So what have we actually done here? We've created a demilitarized zone. We've only allowed ports 53 and on UDP and TCP, and port 80 on TCP to actually get initiated from the outside and come through into here. We haven't allowed anything from down here out yet. If we were to pop onto here, and let's ping 200.20.20.2 should fail. Even though we should have a gateway of last resort on this router, show IP route. I believe we should have that. So the gateway of last resort is not set. Why is this so? That's cute. That's why we've got to respond so quickly. Anyway, it won't go through because this router, if it responded back this way, it should respond to 200.20.21 as the address that initiates stuff. It doesn't have a route to these networks, so it can only respond to that, even though we don't have default gateways and everything set up, so I'll need to set that up for the next video. But that's good up there. 1-to-1 NAT is working fine, so thank you very much, and we'll catch you up in the next video.